In this TI DLP Labs training video, we will discuss the Lumen level requirements of augmented reality head-up displays, or AR HUDs. The brightness of an AR HUD is mainly determined by three HUD parameters: field of view, eye box size, and maximum eye box brightness. We will begin with a brightness overview, layout, and the main light path in an AR HUD. Then we will discuss the main parameters affecting HUD brightness with examples of high and low brightness requirements, and we'll conclude with brightness output across an automotive temperature range and LED selection. Some common acronyms and terms are included here. An AR HUD is an augmented reality head-up display. PGU, or Picture Generation Unit, is the DLP projector and diffuser screen that creates the real image. Field of view, or FOV, is the width and height of the projected virtual image in degrees and determines how large the image appears. The eye box is the area in which the virtual image is visible to the driver. Virtual image distance, or VID, is the distance from the eye box at which the virtual image is located. A digital micromirror device, or a DMD, is the MEMS device at the core of DLP technology. At the end of this training, you will be able to identify the key HUD parameters that determine brightness, understand how these parameters affect the PGU Lumen requirements, determine required PGU brightness for a given HUD design, and identify next steps and recommended LED choice. This is a typical layout of an AR HUD. The DLP HUD is located below the car's dashboard and consists primarily of the projector, diffuser, and large freeform mirror. The projector and diffuser screen make up the PGU and form a real image on the diffuser screen. The light from this image is then reflected off the freeform mirror and again off the windshield to be redirected into the driver's eye box. The virtual image is projected at the VID, and the size of the image is determined by the horizontal and vertical FOV. Two similar terms used in this presentation are brightness and lumens, and while both describe an amount of light, they are different quantities. The brightness of an image is typically described by its luminance. This is a measurement of light per unit area and is measured in candela per meter squared. An image with higher luminance will appear brighter to the observer. Lumens are the unit of measurement for luminous flux. It is typically used to describe the amount of light output from a projector. A projector that outputs a greater number of lumens will create a brighter image. There are three main parameters that determine the required luminous flux output from the projector: field of view, eye box size, and eye box brightness. Increasing the field of view increases the size of the image, so it requires more light. Increasing the size of the eye box requires light to be spread in a larger viewing area for the driver. Increasing the eye box brightness will increase the maximum apparent brightness of the image. Maintaining the same image brightness for a larger eye box or larger field of view requires more lumens from the projector. In an AR HUD design, FOV, eye box size, and eye box brightness are all used as system parameters to determine the lumen requirement from the DLP projector. To help understand the impact of these three parameters, TI has created an Excel tool to estimate the necessary lumens from the DLP projector. This tool can be downloaded by going to the link in the video description. Near the top of the calculator, you will find the HUD requirements section. These include the required maximum brightness of the eye box dimensions, and field of view, along with other HUD parameters. Entering custom numbers in the yellow boxes will recalculate the required lumens indicated at the bottom of the calculator. Below the HUD parameter section are inputs for HUD optical transmission parameters. These values are pre-populated with typical values, but can be adjusted to match individual system designs. These parameters include reflectivity of the windshield, reflectivity of the mirrors, and other typical sources of brightness loss in a HUD system. For instance, we can see if we add a second HUD mirror to the calculator, total HUD optics efficiency decreases from 13 to 12%. Total estimated optics efficiency is included as a subcalculation for reference and is typically low due to the low reflectivity of the clear glass windshield. The DMD to screen section shows many calculated parameters specific to the display chipset used in the PGU. By choosing a different automotive chipset, image characteristics are recalculated and the lumen requirement is updated. We will now look at two example lumen calculations for an AR HUD, one with low lumen requirements and one with high lumen requirements. We can see when decreasing the values for maximum brightness, eye box size, and field of view, the lumens required also decreases. Adjusting the VID does change important HUD properties such as solar loading, but does not significantly affect the lumen requirement. Similarly, increasing the maximum brightness, eye box size, and field of view will all increase the lumen requirement. General trends and approximate lumen requirements can be seen here. As either FOV or eye box size increases, so does the lumen requirement. For an automotive HUD system, it is important to consider how LEDs perform across the entire automotive operating temperature range, as HUD systems are usually operational up to 85 degrees Celsius. As temperature increases, LED efficiency decreases, and HUD brightness can change. It is important to choose the right LEDs to ensure the HUD achieves the maximum brightness targets for all temperatures. The previous example parameters for a small eye box and field of view required 26 lumens out of the projector. We can see that using the DLP3030-Q1 chipset, we can achieve greater than 26 lumens across all temperatures. This chipset will work well in this brightness range and can operate in the lowest power mode, using only approximately 5.5 watts of electrical power. The example parameters for a larger eye box and FOV required 117 lumens out of the projector. The DLP3030-Q1 chipset cannot achieve this lumen output across all temperatures, so the DLP5530-Q1 chipset should be used. This is estimated to achieve the lumen target across the entire operating temperature range. Please see the other resources on ti.com/DLPauto for more information. Thanks for watching the AR HUD Brightness Requirements training video. We learned the three main parameters determining lumen requirements are field of view, eye box size, and eye box brightness, and we saw how the AR HUD Lumen Budget Estimation Calculator can be used to determine the lumen requirements for a specific AR HUD design.